In this lesson, we'll be using a servo motor to learn about these concepts. Pay special attention to the use of for loops, as they are highly versatile and appear almost everywhere in programming, so make sure to master them. A servo motor is a type of motor that can control both the angle of rotation and speed. It's widely used in applications like robotic joints and crossing gates, where you need to move something precisely within a specific range of angles. The structure of a servo motor includes a standard brush DC motor combined with a set of gears, a control circuit, and a potentiometer to detect the amount of rotation. Here's a simple diagram showing a basic servo motor system. When a controller like an Arduino sends an angle instruction, the DC motor inside the servo rotates. The potentiometer detects this rotation and stops the motor once it reaches the specified angle. This kind of system, where changes are detected to determine the next action, is generally known as a feedback control system. This is the circuit we'll be building, which moves the servo motor 180 degrees every 5 seconds. Let's build the circuit. The materials we'll use are an Arduino Uno, a servo motor, and 3 male-to-male jumper wires. Here's the circuit diagram we'll be working with. The servo motor's power supply comes from the Arduino's 5V output terminal. In the case of Arduino, the 5V output terminal is directly connected to the USB port, so it can provide up to 500 mA, which is within USB specifications. While you can't use it to drive large motors, a small hobby servo motor like the one we're using should work without any issues. Next, here is the breadboard diagram. Most servo motors, including the type we're using, have 3 wires: orange for signal, red for power, and brown for ground. Make sure to connect them correctly based on the diagram. Let's set up the circuit. The circuit is now complete. Let's move on to coding. Open the Arduino IDE, click on New File under File, and enter the code shown here. We start with the line #include, which imports a library called servo.h used for controlling the servo motor. Libraries are collections of pre-written code that provide functionality for specific modules. Arduino includes several default libraries, including servo.h. Using libraries can help you write code more easily without starting from scratch, so make the most of them. This library provides 6 functions, so take a quick look at them before proceeding. We also create an object to use the library, which might sound a bit complex, but think of it as bringing a blueprint to life in the real world. Inside the setup function, we use a function from the servo library called attached to assign pin 9 as the signal pin. We're also using the serial.begin function to activate the serial plotting feature, similar to the serial monitor function. In the loop function, we write a repeated process using a for loop. A for loop runs the code within its curly braces as long as the condition inside its parentheses holds true. The parentheses contain 3 parts: initialization, a condition, and an increment. Although there are different ways to write increments, they all have the same meaning, so keep them in mind. In this example, we initialize a variable called angle to 0 and add 1 to it each time until it reaches 180 degrees. The processing inside the loop uses the servo library's write function to set the motor's angle. We then wait for 30 milliseconds and update the current angle value in the serial plotter. This simple code gradually moves the motor from 0 to 180 degrees, 1 degree at a time. Since each step takes 30 milliseconds, it takes around 5 seconds to reach 180 degrees. After reaching 180 degrees, the code waits for 1 second and then repeats the movement from 0 degrees again. Once you've saved the file, press the Upload to Board button in the toolbar to write the program. If everything works correctly, you should see the motor moving 180 degrees every 5 seconds. Also, if you activate the serial plotter from the menu, you'll see a graph showing the gradual increase from 0 to 180 and the subsequent reset to 0. That concludes this lesson. Next, try creating a program that moves the servo motor in reverse. Once you've done that, move on to the next lesson. That's all for now.